Deep inside pretty much every machine out there, there's a component that hasn't really changed all that much for centuries. I'm talking about the mechanical shaft. But what happens when you take cutting-edge artificial intelligence and apply it to this super fundamental piece of engineering? Well, the results are kind of revolutionary. And in this explainer, we're going to break down exactly how AI is reinventing the shaft, literally from the ground up. Okay, so first things first. We really have to get a handle on the core challenge here. Let's call it the perfect shaft problem. For literally centuries, engineers have been wrestling with this fundamental puzzle whenever they have to design one of these critical components. So, just think about it for a second. What's that invisible workhorse that's tucked away inside every single engine, every robot, every wind turbine? The thing that connects the power to the actual motion. Yep, you guessed it, it's the mechanical shaft. That essential link that's responsible for transferring all the torque and rotation. And yeah, it seems super simple on the surface, right? But designing the perfect one, that's always been a huge, huge challenge. And this slide just perfectly lays out the classic engineer's dilemma. You want to make a shaft stronger, right? More durable. Well, that usually means you're also making it heavier and way more expensive. But if you go the other way, make it lighter and less costly, you almost always have to give up some of that strength. It's just this constant, frustrating battle of trade-offs. But what if you didn't have to make that compromise? What if you could actually have the best of both worlds? Well, this is exactly where artificial intelligence steps into the picture. And trust me, it is changing absolutely everything. All right, so let's dive into the first big step in this whole process. Think of it like this: using AI as a brilliant, and I mean incredibly fast, material scientist. Okay, so the old way of picking up materials, it was all about relying on past experience. Flipping through existing data catalogs. It was slow. It was pretty limited. But the new way, the AI way, well, that's what's so cool here. The AI can instantly just rip through these massive databases of materials. It can even come up with totally new combinations that a human engineer might never, ever think of. And look, this isn't just some abstract theory. Take this real-world example from research on UAVs or drones. They used AI to figure out the absolute perfect way to layer composite materials. We're talking stuff like carbon fiber for a transmission shaft. And the result? A shaft that was both lighter and stronger. So what does that actually mean? It means drones that can fly longer or carry heavier stuff, all because they were able to optimize this one single component. Okay, next up, let's talk about predicting the breaking point. Because, it's one thing to build a shaft, but it's another thing entirely to know exactly when and how it might fail under all that pressure. So to do this, engineers have this really powerful tool called finite element analysis, or FEA for short. The easiest way to think about it is like a digital crash test dummy. It lets you run simulations of real-world forces, heat, vibration, you name it, on a computer model to see exactly where it's going to bend or shake or, break. And here's the kicker. AI basically supercharges this whole process. It can create these data-driven models that give you incredibly fast assessments. It can pinpoint those critical hotspots, the exact areas where stress is highest and a crack is most likely to start. And this isn't just about being faster or a little more accurate. This is a game changer. It means engineers can test and improve their designs at a speed that was just unthinkable before. And that leads to safer, more reliable machines for all of us. I mean, take a look at something like heat-treating gears, which, are almost always connected to shafts. AI can predict the internal stress that builds up during that process with way more speed and accuracy than a simulation can do on its own. And that one little improvement, it directly makes the entire system more reliable. Okay, this next part, this is where things start to feel like science fiction. So we've seen how AI can help pick materials and test designs, right? Now let's look at how AI can actually dream up brand new designs all on its own. So this concept is called generative design, and it's really this amazing partnership between a human and the AI. An engineer basically just gives the AI the rules of the game. They'll say something like, okay, I need a shaft that can handle this much load, it can't weigh more than this, and it has to fit inside this little space. And then the AI just goes to work. So here's how it works. It's pretty simple. 1, the human defines the goals and all the constraints. 2, the AI algorithm just goes wild, exploring thousands, maybe even millions of different possible shapes, and a lot of them look totally bizarre, nothing like what a person would come up with. And 3, the AI spits out the best possible designs that check all the boxes. And the result? It is absolutely mind-blowing. The AI comes up with these completely new,
often kind of organic-looking shapes that are perfectly optimized for strength and for resisting wear and tear. We're not talking about small tweaks here. These are genuinely next-generation designs. They make things possible like more efficient engines or lighter robotic arms, stuff you just couldn't do with the old conventional shapes.
You know that old saying, a chain is only as strong as its weakest link? Well, for a shaft, that weak link is almost always where it connects to other parts. So it makes sense that the next big area for AI is to totally revolutionize those critical connection points. So check out this comparison because this is really interesting. On one side, you've got a standard spline connection. You know, those little teeth that lock a shaft into a gear to transfer power? Traditionally, the shape of those teeth is all about being easy to make. It's a compromise. But on the other side, the AI-optimized design, it throws easy out the window and focuses completely on performance. It changes the shape of those teeth just enough to massively reduce stress. And that means parts that last longer and more reliable power in everything from your car's transmission to a giant factory robot. So when you step back and you put all of these pieces together, the materials, the stress testing, the crazy new generative designs, and the connection analysis, you realize this isn't just a handful of new tools. This is a whole new blueprint for how we do engineering. And I think this quote from the source material really nails it. It's a holistic approach. That's the key. All of these AI strategies, they're not separate. They all work together. They feed into each other to create a design process that is just fundamentally better, from the very beginning to the very end. So let's do a quick recap. We've seen AI wear a bunch of different hats here, right? It's the materials scientist, it's the stress analyst, it's the creative designer, and it's the connection engineer. And it's doing all of that at the same time. This right here is the AI design revolution in action. And that really leaves us with one last big question to think about. We've just walked through how AI can make our machines lighter, stronger, and more efficient, all by reinventing a component that's been a cornerstone of engineering for literally centuries. So, if AI can so deeply and profoundly optimize something this fundamental, what's the next frontier? What else is possible with this incredible collaboration between human ingenuity and machine intelligence?